Thank you, Bradley. I'm going to tell you about a project called the Alstonvale Net Zero House, and I'm going to tell you about the important role that an electric drive vehicle plays within this project. This is what the project will look like when it's finished, and this is where we're at today. Now, 4 years ago, Canada's Federal Housing Agency launched a nationwide competition with the goal of spawning 12 demonstration houses across Canada. The Alstonvale Net Zero House is one of these 12 winners of a nationwide competition. And the objectives of, and the competition is named Equilibrium. The objectives of the Equilibrium competition are manifold, but the main objective is energy. The houses were required to be net zero energy consumption. And for those of you who are not familiar with a net zero energy building or a house, it's one that's connected to the utilities grid, and it draws electricity from the grid when it needs it. And so far, it's just like any house. The difference with a net zero energy building is that it generates electricity on-site through renewable resources, and it returns back to the grid whatever it took from the grid, so that in any 12-month period, the balance with the utility is zero, hence the name net zero. So the main objective of this competition was net zero energy consumption by the house. Now, given how bleak the future is in terms of global energy, what we decided to do was to go beyond the scope of the competition objective. So although the competition's focus was on the house and net zero energy consumption by the house, we decided to instead demonstrate the attainability of a net zero energy lifestyle, even within our cold northern climate. And if you consider that the giants on the demand side of energy are buildings, transportation, and industry, then simply connecting the dots gives us some clue as to what that pathway could be towards a net zero energy lifestyle. And for buildings, we would have a net zero energy house whereby the house generates through renewable means all the energy required by a household's shelter and domestic needs. And for transportation, we can achieve net zero energy transportation whereby the house generates through renewable means all the energy required for a household's local transportation energy needs, assuming an electric drive vehicle. And for industry, we decided to focus on food, and I'll tell you a little more about that, where, with respect to food, this house integrates net zero energy methods of food production at the household scale as a way of displacing a household's dependence on the globalized, industrialized food system. So we've got three components: house, transportation, and food. And I'm going to quickly go through each one of them, focusing a little more on the transportation. Now, the methodology to get to a net zero energy house is very clear. Taking the steps and getting actually to net zero energy consumption by a house is not easy. It's not a trivial matter. This is the methodology. You see it behind me. And if you go through these steps, the results are as follows. The big tower that you see on your left is the annual energy consumption of a conventional house, according to Natural Resources Canada, which is just under 40,000 kilowatt hours of energy. Now, what you see to the right is the annual energy consumption of the Alstonvale Net Zero House. It's 7,000 kilowatt hours per year. And if you take into account the electricity that's generated on-site by the household photovoltaics, that energy consumption comes down to zero. The results are dramatic. And I want to emphasize that this is with off-the-shelf products, off-the-shelf materials. It just requires thought. So that's it for the house. On net zero transportation. Now, once you've come to the benchmark, once you've achieved the benchmark of having a net zero energy house, taking the additional step forward to achieve net zero energy transportation is shockingly easy. All it means is putting a little more PV on the roof and picking the right inverter. Now, our south-facing roof is covered entirely with a system called Building Integrated PV Thermal. Well, you can find out more about it from our website. It's an innovative approach. Now, in this BIPVT system, we have 8 kilowatts of photovoltaics. the house requires 5.8 kilowatts to become net zero. That means 2.2 kilowatts are available to charge the battery of an electric car. 2.2 kilowatts, I don't know if you can read these numbers, but 2.2 kilowatts roughly means about 40 to 45 kilometers of average daily use from clean energy. So you see, let me back up a little bit. A house does not have to be a parasite on the grid, but a net zero energy house, an intelligently designed house, can actually be a partner to the grid. A plug-in hybrid or a range extension electric vehicle does not have to be a burden on the grid. In the paradigm that I'm showing here is that the house can actually be the source of energy for the plug-in hybrid. You know, if you've got 3 problems to solve, the worst way of approaching a solution would be to solve one problem today, the second one tomorrow, and the third one the third day. A far better way of solving these 3 problems would be to pause, think, and with one graceful swing of the saber to take all 3 of them down at once. And that basically is the story that I'm trying to tell here. Now, 2.2 kilowatts has a cost, but if that's part of the mortgage of the house, that cost becomes translated to a monthly, and ultimately the cost of operating an electric vehicle in this fashion is roughly 4 cents per kilometer. Now, the cost of operating a Toyota Corolla internal combustion vehicle is also about 4 cents per kilometer. The difference is in the latter, in the case of an internal combustion engine, there are all kinds of environmental costs that are externalized from the calculation. So when you integrate a car and a house in this fashion, a fascinating landscape opens up. I mean, the house can charge the electric drive vehicle, obviously, and that's what the schematic would look like. But the electric drive vehicle can also be an important energy storage resource for the house. So in the case of a power outage, electrons can flow from the car to the house, or the car can also perform certain functions like load leveling for the house. In other words, a vehicle-to-house or V2H relationship. And that's what the schematic might look like in this scenario. Now, of course, here we're talking about one house, one car, but in the scenario where we'll have several thousand, 100,000 electric vehicles on our roads, then all of a sudden these many EVs can collectively become a significant energy storage resource for the grid, right? Vehicle to grid, V2G. Okay, I have to tell you something about food. I know this is not part of the mainstream of this conference, but when I first learned about if you're interested in energy and reducing energy, you have to address food. And let me tell you a story. There was a time when all the food energy available on this planet came directly from the sun through photosynthesis. An agricultural system like that was, or a solar-based agricultural system like what you see, had a very favorable energy balance. In fact, as late as the 1940s, every calorie of energy put into the agricultural system produced 2.5 calories of food. It did that because it was a system subsidized by the sun. Today's industrialized agricultural system, however, has a vastly different energy balance, largely because it has as its centerpiece these vast fields of monoculture, which require a lot of pesticides, which come from oils, fertilizers, which come from natural gas, and hydrocarbons to operate the machinery. And the energy balance of this kind of agricultural system is 3 calories in to produce 1 calorie of food. Doesn't make much sense, but it gets worse, because the agricultural system is just a small yoke within a larger industrialized, globalized food system. And when you take into account transportation, processing, packaging, refrigeration, a bad energy balance becomes even worse. And in our industrialized food system, 10 calories of energy input are required to produce 1 calorie of food. 1 calorie of food that leaves us stuffed yet starved, overfed yet malnourished, and obese and diabetic. So this is a system that is incomprehensibly unsustainable. And for a system to be sustainable, it has to be organic, which describes the agricultural practices, or in other words, a radically reduced reliance on fossil fuels, and it has to be local or regional at the very least, which describes the food distribution and consumption system. So now what we're doing in this project is that all the exterior landscaping will be edible. You'll notice a fish pond to your right, out of which you might be able to pull a fish from time to time, but all the planting will be edible. There's a greenhouse that's under construction in the back. The greenhouse itself will be net zero energy. And you know, in Vancouver, you're allowed to have hens, if I'm not mistaken. In Hudson, which is the location where I'm building this project, we're not allowed to have hens yet unless they're pets. And pets require names, so we will have 2 hens. One will be named H5 and the other will be named N1. So that's the greenhouse. So, concluding thought. You know, a house is not just a home, but if designed intelligently, and that's a big if, because I've worked both in Canada and in the United States as an architect, and the way we design and build houses on this continent is downright shameful. But if designed intelligently, a house is the enabling backbone that supports a household's needs for shelter, mobility, and food solely through a reliance on solar energy and without any greenhouse gas emissions. And now, this house is nearing completion, and we've just started working on a net zero energy neighborhood, and you can say the same thing about a neighborhood. I mean, a neighborhood does not have to be just a dumb cluster of houses, but it can do a great deal more than what this house does. So, thank you.